Okay, for the first lesson, we are going to be looking at graphs of other trig functions, and this is the first part of 2 lessons. So the first graph that we're going to be looking at is the tangent graph. Now you're going to want to add this to your graphic organizer where we had the sine and the cosine graph already done. Now we're going to add the tangent graph to that. So first thing we're going to do is let's take a look at our calculator. So I'm going to go to my y equals. And I'm going to type in the tangent of theta, which I'm just going to use x. Go ahead and do zoom 7, right? 7 is your trig graph. And it should look like this. Okay, so let's draw a sketch on our paper here. So if you look at your unit circle, tangent is sine over cosine. So I'm going to write this up here. So if we want tangent, we're just going to divide sine by cosine, and that'll give us the different values. So there's certain spots on the graph where tangent doesn't exist, like at 90 degrees. If you look at the unit circle at 90 degrees, the value of the point there is 0, 1. So sine over cosine would be 1 over 0, which is undefined. So on a tangent graph, undefined means the graph doesn't exist there. So we're going to actually have some vertical asymptotes. So the asymptotes for tangent would be at 90. There'd be another one at 270. That would also give you undefined. And then on the negative axis, negative 90 and negative 270. And then if we look at the different values of tangent between negative 90 and 90, it makes this curve. And then it repeats. And it goes on forever and ever. So some important things to note about the tangent graph is the domain. Domain, it's all real numbers except for where we have the asymptotes. So the asymptotes occur at increments of, well, it starts at 90 degrees, but then it occurs every 180 degrees. So how we would write that, we're going to use a formula, except for, and so not equal to, pi over 2, that's 90, plus every increment of 180. So how I would write that is n pi. And then the range is all real numbers. This graph goes everywhere up and down. Some other important things to note are the amplitude. The amplitude of this graph is infinity. It doesn't have a highest point, it goes forever. The period, so this is also a little different. The period of a trig graph, it only takes 180 degrees for it to repeat. So 180 or pi in radians. Okay, so let's look at cotangent next. So I'm going to graph that on my calculator. So I'm going to go to my y equals, and I'm going to type in cotangent. So cotangent would be 1 over tangent. And it's going to look pretty similar to tangent. It's just going to go the opposite direction. It also has asymptotes in different spots. So if you look at your calculator, our first asymptote is at 0, and then the next one is at 180, and then it just repeats. So I'm going to draw those in first. I've got an asymptote at 0, 180. The next one would be at 360, negative 180, negative 360. And then I'm going to draw that curve in using my calculator as a guide. Okay, so let's talk about domain. The domain is all real numbers except, so not equal to, where we have asymptotes. So our first asymptote occurs at 0, and it repeats every 180 degrees. The range is all real numbers. And the cotangent graph has a similar amplitude and period as tangent. Its amplitude is also infinity, and the period is also pi. Okay, so we're going to look at the other trig functions. These ones we don't use as often. So I'm going to look at cosecant next. Cosecant on our calculator, when we go to graph that, we type that in as 1 over sine. And this looks very strange. So cosecant is the reciprocal of sine. So everything's pretty much opposite. So why it looks so funny? So anywhere sine is 0, the reciprocal, when we flip it, is going to be undefined. So that's why sine, when I graph this, I'll show you what sine looks like and it'll make a little bit more sense. So let's start with our asymptotes. It looks like we have one at 0, 180, and negative 180. So I'm going to draw those in first. Negative 360 and 360. And then we have the graphs go to 1 and negative 1. So this first graph looks like this. So there's the cosecant graph. Now if I graph sine over top of this, you don't have to do this. You can just look at my video here. Here's the sine graph. So look how opposite it is. Anytime sine is 0, cosecant is undefined. Now anytime sine has a maximum of 1, cosecant has a minimum of 1. Anytime sine has a minimum of negative 1, cosecant has a maximum of negative 1. So let's talk about domain and range. Domain is all real numbers not equal to where we have asymptotes. We have asymptotes at 0, and it repeats every 180 degrees, so pi n. And then the range, it's everywhere except for in between negative 1 and 1. So we could write that as negative infinity to negative 1 and 1 to infinity. Okay, let's go to the last graph, which is secant. So secant is going to look a lot like cosecant, but to graph it, we're going to put 1 over cosine. So just like sine and cosine look similar, secant and cosecant look similar. So if I pay attention to this graph here, I'm going to start with my asymptotes. I have an asymptote at 90, 270, and then it repeats down here, negative 90, negative 270. And then I'm going to draw in my graph in between. Okay, so let's go through some examples here. Number 1 says sketch the graph of y equals tangent of x over 2 by hand. So one thing we're going to want to look at is on your formula sheet, we had formulas for sine and cosine. There's also formulas we're going to use for tangent. So on your formula sheet down at the bottom, I want you to add in the formula for tangent, and I'll just put it at the top here. So y equals a tangent of k theta plus c. A is still amplitude, but the period for tangent is not 360 over k, it's 180 over k. Everything else is going to be the same. So the phase shift is going to be the same, negative c over k, and the amplitude. So now amplitude for tangent, it's still infinity. So that number in front really doesn't make a difference. So let's go to number 1. tangent of x over 2. So I'm going to, on my calculator, get tangent drawn. Tangent of x, just so I can see the graph, what it looks like. And I'm going to make a list, just like we did before, of all the important things I would need to know. So amplitude of tangent is always infinity. Period, though, is 360 over k, normally for sine and cosine, but for tangent it's 180 over k. K in this problem is the number in front of x, so it's really 1/2. 180 divided by 1/2 is 360. So it's actually going to stretch this graph out. Normally tangent goes from 180, so now I've got to stretch it out. Now if I look at this normal tangent graph, one period, I'm just going to take one period when I graph these, goes from -90 to 90, right? That's one curve of the tangent function. So that's a stretch of 180 degrees. Now I want to stretch this to 360. So if normally my tangent graph goes from -90 to 90, and that's 180, I'm going to want to stretch it from -180 to 180, and that would stretch it to 360 degrees. So I'm going to draw that -180 to 180, and I'm going to plot my asymptotes, and then draw my tangent graph in. So it's the same shape, but instead of a period of 180, I now have a period of 360. So you only have to, when you draw these, you only have to pick one period and do that. But if you wanted to do another period, you could go from 180 to 360. Oops, sorry. 180 to 420, I guess, would be the next one. And then that would be your next period. Okay. So, number 2, we're going to sketch the graph of y equals -3 tangent of 2x. So same thing. Now, this 3 in front doesn't change the amplitude at all. It's still infinity, but it might stretch it a little bit. You're not going to notice, though, because when you stretch infinity, it doesn't really change the way the graph looks. This negative, however, this is an x-axis reflection. So normally if our tangent graph looks like this, we're going to reflect it about the x-axis. So now it's going to look like this. Okay, the other thing is I've got a period change. So the period is 180 over 2, which is 90. So it's really going to shrink the graph. So again, if I look at my tangent graph, normally it goes from -90 to 90. I'm just looking at one period. Now I want to shrink this down and have a distance of 90. So that means I would have to go from -45 to 45. That would give me the correct distance. So I'm going to draw that in just so I have it. -45 to 45. And draw in my asymptotes. And tangent normally looks like an increasing function from left to right. We want to do an x-axis reflection, so we're going to make it go the other direction. Now, if you want to double check your work, so now I'm technically done. I drew one period. That's all you have to do. If I want to check my work, I would go to the graph and or the y equals, and in line 2, I would type that in -3 tangent of 2x, and this is going to be in red on my calculator. Now it's going to draw all of them in my viewing window. But if you just look at the one that we drew, it's the opposite direction, and it goes from -45 to 45. So technically, in one blue graph, I should have 2 red graphs fit. Okay, so that concludes part 1. Feel free at any time. You could pause. You can go back and rewatch. Email me if you have any questions. Make sure you watch part 2 next.